Hi guys, this is Allison from Allykatkreations. How are you? Please like, share, and subscribe if you haven't done so already. And if you get anything from my work, a connect the dot, an epiphany, a mind-blown moment, a new author to read, a new book to explore, please consider supporting my work. All the links will be at the bottom of the description. The fun aspects of the quantum world. Fun times. I still have to find my WD-40 chair. So I hope everybody having a good end of the week. I know I have. Miracle happened today. Miracle. Little Thor, my outdoor kitty that I've been taking care of, came in the house today. He came in and then left. I left the door open and then he literally came in and was on the adventure. I didn't even know he was in the house until I go look in the cat's room and there he is. It was the cutest thing in the world. He got a little afraid, of course. New situation, new smells, new everything. So he ventured down where I am, down here. He hid out for a little bit. And then 2 hours later, he decided, I want to go, which is fine. So he left. And then I put the garbage out. And then I saw him outside. And he started falling asleep. He's the cutest thing in the world. So I had a very productive day, to say the least. Quantum AI and metaphysical ponderings, because I haven't done this in I have, but haven't in a bit. I'm going to read some articles that popped my interest, and I'm going to read them with you, because why not? This is from Live Science. livescience.com. Our entire galaxy is warping, and a gigantic blob of dark matter could be to blame. The blob of dark matter doesn't bother me as much as the warping. This is by Ben Turner. An invisible halo of misaligned dark matter could explain the warps at the Milky Way's edge. The gigantic blob of invisible dark matter has bent our galaxy out of shape, a new study suggests. Scientists initially believed that the Milky Way was a flat disk. Oh, here we go. Dominated by 2 spiral arms trailing stars from a central bar. But measurements taken since the mid-20th century reveal that it's bent, inexplicably out of shape. The warping occurs mostly at our galaxy's borders, where some regions bend downward while others flare upward, giving it the look of a crushed sombrero. Interesting. Now computer simulations, here we go again with the computer simulations, may have revealed the cause of a mysterious event that knocked our galaxy's invisible halo of dark matter out of alignment. These results, in combination with data in the stellar halo, provide compelling evidence that our galaxy is embedded in a tilted dark matter halo, the researchers wrote in the study. Dark matter is mysterious, so is black goo, and somewhat contradictory type of matter. It makes up 85% of this universe's matter, but because it doesn't directly interact with light, it is completely invisible. Or so they think. However, scientists observe its gravitational effects on its surroundings. Dark matter makes its presence known by accelerating stars to otherwise inexplicable speeds as they orbit galactic centers, warping distant starlight, and by giving shape to the Milky Way's galactic halo. The galactic halo, a vast sphere of stars floating like leaves on dark matter, rests just beyond the spiral arms of the Milky Way. In 2022 study, astronomers investigated this region using the European Space Agency's Gaia spacecraft, which maps the positions and movements of the Milky Way, roughly 2 billion stars. By pouring through Gaia's data, they discovered that the stars suspended in the galactic halo were strangely off-kilter. To see what an unbalanced stellar halo might mean for the dark matter halo, it is suspended. The researchers used a computer model to recreate a young Milky Way-like galaxy with dark matter halo tilted 25 degrees with respect to its disk. After simulating the galaxy over 5 billion years, the researchers found that they had created a very similar galaxy to our own. Here we show that a dark halo tilted the same direction as the stellar halo can induce a warp and flare in the galactic disk at the same amplitude and orientation as the data the researchers wrote. So, just ponderings here, just thinkings, brainstorming. Why, deep question here, are they using computer simulations? My short answer is because it's made up. I'm not saying dark matter is not made up. I think that is utterly real. But the way in which our universe looks outside of the firmament may be vastly different from these simulations, and they don't want to tell the public or these researchers the real truth, because only a select few know about it. And that is because shit's hidden. Just a thought. Just a thought. I mean, again, computer simulations aren't a negative thing, but if you're allowing a computer to dictate reality to you, things that could possibly be, but not, who's making the software behind the computer simulation? This goes way deep. It's not just thinking, oh, it's a computer. No, who's making and designing these simulated programs? What are they putting into these programs? And if the galaxy is warped, cool. Is there anything any one of us could do about it? No. No. But the idea that they say that is invisible, dark matter is invisible, then tell me what they're working with at CERN. That's an invisible phantasm, ectoplasm, the etheric realm. What are they working with if they have the largest collection of dark matter if it's invisible. Go, please explain that to me. That's why I read these. I might not believe in anything that they're saying, but there's a lot of juicy shit inside of these that it opens up other conundrums of other bullshit. Warping. If the forces of positive and negative polarity are fighting over this realm of existence, then one could ponder that they're using forces outside of our comprehension to warp space-time to get us, because we're on the Sagittarius spiral, we're on the arm of the spiral. We're not anywhere near the center. We're really far removed from everything else that's going on. And there is other galaxies in and around us, but looks like they're close, but they're far. And at the same time, it could just be the Truman Show and the light falls down out of the firmament and it's cold Sirius A. You know, unless and until we venture beyond Antarctica, we see things for what they really are. We're really not going to know. It's just ponderings. It's just metaphysical. It's just thinking. We really don't know. I'm just making these ideas, bringing them to light because I think it's something worthy to think about, because people are spending a lot of money for these experiments to be created and done, and these simulations to be made and done. And at the crux of it all, what for what? Oh, we're going to find out about reality. Most of us already know how reality works. And there's debate in that as well. But we all know something's off, something's askew. And these people make a big buck by lying about it. This is from physicsworld.com. And again, all the links will be in the description below the video if you're interested in reading it for yourself or seeing the pictures. Gravitational waves could reveal dark matter transforming neutron stars into black holes. Interesting. A team of theoretical physicists in India has shown that gravitational waves can reveal the role that dark matter could play in transforming neutron stars into black holes. Dark matter is a hypothetical, invisible substance invoked to explain the curious behavior of large-scale structures such as galaxies and galaxy clusters, behavior that cannot be explained by gravity alone. If it exists, dark matter must interact with ordinary matter via gravity. However, some models predict that dark matter could also interact with ordinary matter through very weak non-gravitational interactions. Once again, why does CERN have the largest collection of dark matter? If it's theoretical, hypothetical, and invisible. Or do they really have the largest collection of black goo, which if you do Super Soldier Talk or any of the other galactic shows that talk about black goo, it ain't good. It ain't good. It's not kosher. Yes, I used it. I went there. Feeble but sufficient. Non-gravitational interaction means that dark matter particles are expected to have some sort of interaction with protons and neutrons. Oh, that's a name. I'm trying to print. I'm going to butcher this poor person's name, and I apologize. Batachia, Batachira. I made my best attempts. It is spelled like that. Is a graduate student at the Tata Institute of Fundamental Research in Mumbai, who adds these interactions may be very feeble, but they may be sufficient enough to allow the dark matter particles to become captured inside a neutron star. Neutron stars are the dense core remnants of massive stars that have exploded as supernovas. They are very small, perhaps a dozen kilometers across, but with mass greater than the sun. The core of a neutron star is so dense that it could increase the probability of interactions between normal matter and dark matter. The maximum theoretical mass that a neutron star can have is 2.5 solar masses, but in practice, most are much smaller, around 1.4 solar masses. Neutron, sorry, I want to say neutrino, for whatever the reason is. Neutron stars that are greater than 2.5 solar masses will undergo gravitational collapse to form black holes. Stellar mass black holes can also form directly from supernovae, explosions of large stars. But theoretical modeling has suggested that black holes should not exist at 2 through 5 solar masses. Until recently, this was supported by observational evidence. However, beginning in 2015, observations of gravitational waves from the merges of black hole pairs revealed the existence of black holes within the mass gap. For example, GW 190814 was a gravitational wave event detected in 2019 that involved an object with between 2.50 through 2.67 solar masses. Another mystery event was GW 190425, also detected in 2019, where the combined object had a mass of 3.4 solar masses. This is a substantially higher total mass than any known binary neutron star system. The Indian Institute and a University of California, Berkeley have suggested that dark matter accumulating within the core of a neutron star would increase the core density to the point that it collapses into miniature black hole. This black hole would then grow and engulf the neutron star. The result would be a black hole with a lower than expected mass. And the detection of such low mass black holes would be tantalizing evidence for the dark matter. Again, I'm skipping around. Sorry, guys. Indeed, the key advantage of using gravitational waves to search for evidence for dark matter is that it is the most sensitive means we have for detecting the faint non-gravitational interaction of dark matter with normal matter. This is because observing gravitational waves is not subject to the neutrino floor, which limits experiments that aim to directly detect dark matter. The floor refers to the fact that the neutrinos are a significant source of background noise in dark matter. Detectors such as Lux Zeppelin. So 2 articles, very different. It boggles my brain because people get paid to search for invisible stuff, but it's not really necessarily invisible, it's metaphysical. And the fact of the matter is, we study what we perceive or what we don't perceive, and all possibilities are endless. I'm just curious what timeline this is all on. Another article that caught my eye. This is from quantumagazine.org. How Maxwell's Demon continues to startle scientists. The thorny thought experiment has been turned into a real experiment, one that physicists use to probe the physics of information. This is by Jonathan O'Callaghan. It took physicists 115 years to tame Maxwell's demon. The universe bets on disorder. Imagine, for example, dropping a thimble full of red dye into a swimming pool. All of those dye molecules are going to slowly spread throughout the water. Physicists quantify this tendency to spread by counting the number of possible ways the dye molecules can be arranged. There's one possible state where the molecules are crowded into the thimble. There's another where, say, the molecules settle in a tidy clump at the pool's bottom. But there are uncontrollable billions of permutations where the molecules spread out in different ways throughout the water. If the universe chooses from all the possible states at random, you bet that it's going to end up with one of the vast set of disordered possibilities. Seen in this way, the inexorable rise in entropy or disorder, as quantified by the second law of thermodynamics, takes on an almost mathematical certainty. So, of course, physicists are constantly trying to break it. One almost did. A thought experiment devised by the Scottish physicist James Clerk Maxwell in 1867 stumped scientists for 115 years. And even after a solution was found, the physicists have continued to use Maxwell's demon to push the laws of the universe to their limits. In the thought experiment, Maxwell imagined splitting a room of gas into 2 compartments by erecting a wall with a small door. Like all gases, this one is made of individual particles. The average speed of the particles corresponds to the temperature of the gas. Faster is hotter, but at any given time, some particles can be moving more slowly than others. What if, suggested Maxwell, a tiny imaginary creature, a demon, as it was later called, sat at the door every time it saw a fast-moving particle approaching from the left-hand side? It opened the door and let it into the right-hand compartment. And every time a slow-moving particle approached from the right, the demon let it into the left-hand compartment. After a while, the left-hand compartment would be full of slow, cold particles, and the right-hand compartment would grow hot. This isolated system would seem to grow more orderly, not less, because two distinguishable compartments have more order than two identical compartments. Maxwell had created a system that appeared to defy the rise of entropy and thus the laws of the universe. He tried to prove a system where the entropy would decrease, said Laya Delgado Calco, a physicist at King's College London. It's a paradox. That it is. The second vital piece of the puzzle was the principle of an erasure. In 1961, the German-American physicist Rolf Landier showed that any logically irreversible computation, such as erasing of information from a memory, would result in a minimal non-zero amount of work converted into heat dumped into the environment and a corresponding rise in entropy. Yeah. Landier's erasure principle provided a tantalizing link between information and thermodynamics. Information is physical, he later proclaimed. So I have light bulbs blaring out of my head. Blaring. Sorry, guys. It's gonna rain or something's up with my back. When people say they were abducted and taken into a craft and then they erased their memories, I could only imagine why the rooms are always reported by memory cold, or going into QHHT sessions that people more spontaneously feel cold than they do hot. That could be the conundrum here solved. They have to keep the room temperature cold, because if they're erasing information, which is physical, that means it's going to get hot in there, and then their technology won't work. Just a pondering. In 1982, the American physicist Charles Bennett put the piece of the puzzle together. He realized that Maxwell's Demon was at the core an information processing machine. It needed to record and store information about individual particles in order to decide when to open and close the door. Periodically, it would need to erase this information. According to Landier's erasure principle, the rise in entropy from the erasure would more than compensate for the decrease in entropy caused by the sorting of the particles. You need to pay, said Gonzalo Manzano, a physicist at the Institute for Quantum Optics and Quantum Information in Vienna. The demons need to make room for more information, led to a net increase in disorder. This is interesting. Then in the 21st century, with the thought experiment solved, the real experiments began. The most important development is we can now realize Maxwell's Demon in laboratories, said Sagwa. In 2007, scientists used a light-powered gate to demonstrate the idea of Maxwell's Demon in action. In 2010, another team devised a way to use the energy produced by the demon's information to coax a bead uphill. And in 2016, scientists applied the idea of Maxwell's Demon to two compartments containing not gas but light. We switched the roles of matter and light, said Valkoverdra, a physicist at the University of Oxford and one of the study's co-authors. The research were ultimately able to charge a very small battery. The team led by Manzano wondered if there was a way to implement something like Maxwell's Demon, but without the information requirements. They imagined a two-compartment system with a door as before, but in this case, the door would open and close on its own. Sometimes particles would randomly separate themselves into hotter and colder compartments. The demon can only watch this process and decide when to turn the system off. In theory, this process could create a small temperature imbalance and therefore a useful heat engine. If the demon was smart about when to end the experiment and lock any temperature imbalance in place, much as a smart gambler on a hot streak knows when to leave the table, you can either play all night on the roulette table or you can stop if you win $100, said Edgar Rollin, a physicist at the International Center of Theoretical Physics in Italy, who was a co-author on the study. We are saying we don't need such a complicated device as Maxwell's Demon to extract work in the second law. We can be more relaxed. The researchers then implemented such a gambling demon in a nano-electronic device to show it's possible. For the time being, though, our laws of the universe are safe. That's really freaking fantastic. Thank you for stating that. For fuck's sake. I'm going to read that again. For the time being. Hint. What? Though our laws of the universe are safe. Oh, are you telling us that they're not going to be safe? What the fuck is that? Even when placed under the greatest scrutiny. What has changed is the understanding of information in the universe. And with it, our appreciation of Maxwell's Demon. First, a troublesome paradox, and now an invaluable concept, and one that has helped to illuminate the remarkable link between the physical world and information. For the time being. Because like I said in past episodes of this, a lot of people don't even watch these episodes that I do with this topic because A, it's above a lot of people's heads. B, I can't do the mathematics in physics. Can't. I just got past chemistry. I can't do the math. I can conceptualize things. I could see things moving in my head and I could see their experiments being, but if someone were to ask me to make the mathematical equation for it, yeah, no, sorry. Need somebody good at math to do that stuff for me. I'm not a math person. I'm a creative. Either way, though, that statement right there is very troubling. In this reality, this realm of thinking, thought, consciousness, whatever you want to call it, the laws of the universe, who are they devised by? This is some good research material right here. That last, I mean, you might not be interested in this demon study, but who's devised the laws of physics and the universe at large? Because most laws are observational. Could there be hidden messaging in those laws that would help us solve many more conundrums that are happening in our paradigm right now? Because let's face it, there are beings of way higher consciousness, way higher knowledge and abilities. And in their realms, I bet you the laws of physics and science are completely, utterly different. Probably similar, but more advanced, more banana nuts. I believe we are living in an ontological holographic simulated matrix because we run off of numbers. Our numbers are, the equations are always streamlined and always baseline, and it always corresponds. Everything is mathematical. Everything is mathematical in our universe. And that's just here in this density that we are observing this. What happens if the game moves up and we move up and we change the game? You know, there's a lot of people in military circles that, you know, had told others before they passed away that the technology that we see now is 20 to 30 years behind. And that these government agencies or these offshoots have a lot more advanced technology. And I wouldn't be so far-fetched to say that in a lot of these television shows where you see like a sheet of glass and you see the holographic components where you can interact with it and touch it, we're not far off. In Transylvania Sunrise, they talk about this technology in the book. It's not so far-fetched. The Jetsons wasn't so far out of the realm of far-fetched. I just don't believe that we're going to have flying cars. Can you imagine the irresponsible people that are driving a vehicle now flying? Yeah, I don't think so. And instead of driver's license, we'd have to get pilot license. I doubt half of the world would pass. Just putting that one out there, regardless of anything. That Jetson's life is probably on another planet, given some little bit of validated truth that it might be our future. But I mean, Rosie the robot does exist. Do I want a Rosie the robot? Absolutely. Who wouldn't want Rosie the robot? Most of that technology that the Jetsons portrayed in that cartoon is here in different forms, but it's here. Dick Tracy, smartwatch, go gadget. It's, you know, we have to look at predictive programming as in a black and white kind of thing, because there is things that were predicted that are not of our demise, is of our detriment. It's in the course of what will help us. Like if we look at the X-Files show, I would say it looks fictionalized for a reason. It's full disclosure on everything. It always has been. The show, if you've watched it, even the crazy mutations of things, this is what they do down there in my labs. This is the stuff that they experiment on. And there are people that have, unfortunately, some of these mutations because they were lab experiments. Don't blame the vehicle for that they don't know. So when we're looking at these physicists and mathematicians and all these theorists and beautiful minds, you can't really blame them for not understanding the depths of how evil the system has been and was developed by. They're working within it. And I bet there are some really good, without their knowledge, light workers in there infiltrating so that we're not going to go kabloomy. But that's not to say that you got to take responsibility. If you are a physicist, if you are a scientist, not to do an experiment with unwavering knowledge that you could be taking us out or sucking us into something that you have no idea how to get us out of, or creating something that could be turned into something very negative and maniacal. If we look at the instance of the lab workers in all these pharmaceuticals, right? Most people take a job to teach. Most people take a job to do something because they believe in it. They want to help the greater good. And then when they get in there and they sign their contracts and they're making a bit of money and everything seems like they're helping humanity, 10, 15 years down the line, if they were somebody that came up with some crazy invention, they looked at a peptide and it did something different that could save humanity, right? Did they know that someone was going to do a loop-de-loo and fuck with it and reverse what it was meant to do in the first place? No, they didn't know that. A lot of these people think they're helping humanity, and they're thinking that their discoveries are going to be a betterment in some way. What a lot of them don't comprehend is how their experiments are so compartmentalized that it's visually seen that and deemed that what they're discovering and what they're doing is pure good, and it's pure, just for their own shits and giggles for the most part. I mean, do we really care about black matter? If it's hypothetical and invisible? But then why does CERN have the biggest facility housing this shit? And if it's invisible and hypothetical, then why? What is that facility really for? So see, this is why I read these articles. It's because a larger picture starts opening up for my mind, and then the rabbit hole begins. I mean, that last article, hello. The bottom part of that article is basically saying, things could change if we fuck up. Next article. This is from astronomy.com. Do black holes have bottoms? Black holes are surrounded by a spherical event horizon, and your spaceship could indeed fly under, over, or around it. My spaceship? What? My spaceship? By astronomy staff, published September 14th of this year. I'm sharing screen because I want you. I don't know if you can see my cursor on it disappeared. What the? Sorry, guys. I'm going to try that again without my cursor. Okay. I don't know if it's disappearing, but what I wanted to show you was there's, the netting. I call it the netting, and then there's a star that can bounce in on the netting. And then you have the funnel, and it's showing the black hole, the event horizon, and then the singularity at the bottom. I don't know if that disappeared, and I'm sorry if it did, because it disappeared on my screen. Is there a bottom of a black hole? Can a spaceship travel under one? Or does it go on and on and on? Rick Tello, Bisbee, Arizona. I suspect your question arises from seeing diagrams like the one at the upper right, which attempts to show how general relativity results in the curvature of space-time around massive objects. At the top left, it is easy to see how a massive object, a star, distorts the fabric of space-time represented by the grid, but clearly has a bottom and doesn't break through the grid. That's why I call it netting. At the lower right, the black hole looks like a funnel with no bottom, as mathematically black holes are points with mass but no volume. This means they have infinite density, and so space-time has infinite curvature. But there's a key problem with this picture. The best explanation I've found comes from one of my favorite textbooks. Another problem. Exploring Black Holes, Introduction to General Relativity by Irwin F. Taylor and John Archibald Wheeler. Oh, there's an incorporation involved in this, so we can just say we can null and void this article. Anywho, again, there's truths amongst the lies. In it, the authors explain that such figures called embedding diagrams are meant to represent the complex geometry. My screen keeps moving. Gremlin, stop! Of curved space within the limit three-dimensional Euclidean perspective printed on the page, but flat Euclidean geometry is not curved space geometry, they write. Therefore, we expected embedding diagrams to misrepresent curved space in some ways. They lie! How do they lie? With regard to your question, the vertical aspect of the diagrams is not a real dimension of space-time. The concept of depth has been artificially added to the diagram to add the reader visualize how gravity affects space-time. Space-time is not a flat two-dimensional grid. We just need to draw it that way on a page. So a black hole is not really a funnel-shaped object sitting in space and sucking down matter into only one direction. In addition to being an artificial representation, the embedding diagram also attempts to show what is happening inside the black hole's event horizon, the point of no return. There's fake black holes, real black holes are surrounded by a spherical event horizon, instead of which gravity becomes the dominating force and weird things happen, causing our laws of physics to break down. But outside the event horizon, the universe acts pretty normally. So you can picture a black hole from afar as a sphere, for example, as seen in the movie Interstellar. And your spaceship can indeed fly under, over, or around a black hole anytime, which way it chooses, as long as it doesn't come too close. So the choice of wording here is a real black hole. So there's fake ones. I believe in black holes. And after the medium reading, I was taken through a wormhole. So those exist. And I know that for my own essence. I believe black holes exist. I don't believe they exist the way they're being portrayed. Again, if we're living in the Truman Show, let's just put that analogy out there. Think about it. I'm not asking you to believe that you do, But just think about the show, the stage which you're on, how much of it that we don't know, right? People like me can see other dimensional spaces. I could see sometimes ectoplasm and the ether that forms into physical matter. Mists, black shadow figures, stuff of that nature. I've seen it with my own two eyes. I felt my father touch my hand. So these are things that, again, unless you experience, it's hard to believe. But if you have experienced this stuff, great. Have any of us experienced a black hole? Do we know if there's a firmament or not? Do we know, it doesn't matter if it's flat or round, the round doesn't make any sense, but then are there planets outside of the dome? Or is it all an illusion here to keep us distracted? And if there are people working on miniature black holes, a black hole can happen in any damn fucking paradigm then. So explain to me space. Is a whirlpool, you know, some people feel that above the firmament is water as above to below. So is a whirlpool that sucks things to the bottom of the ocean, is that necessarily a black hole? Or is that something dictating what a black hole does? I know I've read in many multiple people and spiritual people talk about black holes, how they're trying to get us into that system. And then once it hits the singularity and the event horizon, we return to God in space dust, from dust to dust. It could be, it's a big question. A lot of this is questioning. That's why I love reading these articles, because I find things, I get epiphanies, and then I start researching. Or I keep reading more to see where they're going and what narrative they're trying to steer. Next article. Freethink.com. Scientists see rarest event ever recorded in search for dark matter. The team caught a glimpse of a process that takes quadrillion years. Yeah, something like that. Scientists have observed an extremely rare particle physics event using a detector that's hunting for dark matter, the mysterious material that physicists have yet to observe. Here we go again with the unobservable thing. That's a theme of this week, unobservable matter. In a paper published in the journal Nature, researchers with the Exxon collaboration said they observed the radioactive decay of a substance called xenon 124, an isotope of the element xenon, a colorless and odorless noble gas found in tiny amounts in the atmosphere. The event, 2-neutrino double electron capture, has eluded scientists for decades. It happens when 2 protons in a nucleus are simultaneously converted into neutrons by the absorption of 2 electrons from one of the atomic shells and the emission of 2 electron neutrinos. After this occurs, the event shoots a predictable cascade of X-rays and Auger electrons that scientists look for using an ultra-sensitive detector buried about 5,000 feet beneath Italy's Gran Sasso mountain, where it's shielded from cosmic rays. Well, well, well. What do we have here? Another mountain to explore and all the goodies within it. Oh. I'm sorry, because I'm just writing this down because what a lot of countries have buried in their freaking mountains. I mean, who knows these things? We have shown that we can observe the rarest events ever recorded. Ethan Brown, a professor of physics at Rensselaer Polytechnic Institute and co-author of the study, told Newsweek. The key finding is that an isotope formerly thought to be completely stable has now been shown to decay on an unimaginable long time scale. How long? Oh, I was so off on the freaking number. How long is the time scale? The team estimated the xenon 124's half-life is about 18 sextillion years. I said quadrillion. Quadrillion. I didn't say sextillion. Which is then 1 trillion times the age of our universe, according to the team. It's the slowest process ever measured directly, the team wrote in a statement. It is an amazing to have witnessed this process, and it says that our detector can measure the rarest thing ever recorded. We designed the Xenon 1T experiment to look for dark matter, a new kind of matter that makes up 85% of the mass of the universe, but interacts so rarely that it's never been observed. This experiment is so sensitive to very rare events that we can make all kinds of other rare physics measurements. One of those is this decay of xenon 124. Although our primary goal was always the discovery of dark matter, we knew there was a good chance we could see this rare decay, so we set out to do so. To get the good chance, the team had to expose their detector to a huge amount of xenon atoms by stocking it with 3.2 tons worth of liquid xenon. Xenon 1T is a giant vat of liquid xenon surrounded by light sensors, Brown said. When dark matter collides in the xenon, or when a radioactive decay occurs inside, we get a tiny flash of light and a little bunch of charge out of the xenon. We measure these with the light sensors and reconstruct everything we can about the original event that caused the light charge. Although the team didn't observe dark matter, which is primarily purpose for the detector, the recent observations could help scientists learn more about neutrinos, one of the latest understood fundamental particles in the universe. It proves that xenon detector technology we can use for dark matter is much more versatile. Graduate student Christian Wittweg, PhD student at the University of Münster in Germany, told Gizmodo. We get all these cool analyses for free after having built an experiment sensitive enough to hunt for dark matter. The team plans to use its new Xenon T detector to continue hunting for dark matter, the elusive matter that's estimated to comprise about 26.8% of all content in the universe. Yeah, we're seeing a trend here, aren't we? This next article is from space.com. Supermassive black hole accretion disks seem on edge for the first time. By Robert Lee. Lee, maybe. Astronomers have viewed the outer region of an active supermassive black holes accretion disk, thereby improving our understanding of these feeding cosmic monsters. Astronomers have observed the outer edge of a disk of matter surrounding a feeding supermassive black hole for the first time. These observations could help scientists better measure the structure that surround these cosmic monsters, understand how black holes feed on those structures, and put together how this feeding influences the evolution of galaxies that house such phenomena. Feeding supermassive black holes sit at the hearts of regions of incredible brightness called active galactic nuclei. Immediately around these black holes, which can have masses millions or even billions of times greater than of the sun, lies a swirling disk of gas and dust that is being gradually fed to the central supermassive object. The incredible gravitational influence of such supermassive black holes causes matter in accretion disks to reach temperatures as great as 18 million degrees Fahrenheit. This causes the structure to emit radiation across the electromagnetic spectrum, from high-energy gamma rays and X-rays to visible light and infrared light and radio waves. These emissions from AGNs, which are also called quasars, can be so bright that they outshine the combined light from every star in the galaxies that surround them. Which, for those of you who watch IQ, this is where the conundrum of W.C. Vetch comes into play when he calls a certain person a quasar. Is it literal or figural? Just my thinking. Yet, even with this powerful output, because accretion disks are relatively small and many are located in incredible distant galaxies, they are difficult to directly image. But as an alternative, astronomers can use the full spectrum light from an accretion disk to understand its physics and even determine its space size. Okay, Allison's brain is going off on a tangent, and it's probably a good observation, maybe not, I don't know. But if Prime Creator created all of this, and including these black holes, we have nothing to fear. It's a negative polarized, possibly positive polarized, we don't know. But perhaps if you look at, I was a lifeguard for 18 years. If you look at pools and how things get sucked, right? Perhaps black holes are just the dust busters or the Dyson vacuum cleaners of the universe. Maybe it's supposed to be there, not to cause ultimate annihilation to the things it sucks into itself, possibly taking the litter out of space, sucking it in, and recreating it to be something else. That's if you're not being sucked into a black hole and there's not something on the other side. We can only, I believe that black holes are portals. I don't necessarily believe that they can destroy. I'm not saying that they don't. But maybe it's the cosmic vacuum cleaner cleaning up what's around it that's no longer viable to us or any species of life. Just a thought. This is the technique adopted by a team led by researchers from the Instituto Nacional de Pesquisas Especias, Brazil. I totally butchered that. I apologize. I took Spanish, but that looks like Portuguese. Okay, that's a really long name in Danny Mara Diaz dos Santos and Alberto Rodriguez Adila studied the accretion disk of the distant quasar. Roman numeral 3, ZW002, located at the heart of the galaxy Miser 106M, lives some 24 million light years away from Earth in the constellation Canis Ventic. The team saw for the first time near-infrared emissions lines in the spectrum of light coming from the quasar's accretion disk. Those lines helped the researchers size this plate-like structure from which the supermassive black hole determined, to have a mass between 400 and 500 times the mass of the sun feeds. This galaxy gives us valuable insights into the structure and behavior of the broad line region in the particular galaxy, shedding light on the fascinating phenomena happening around supermassive black holes and active galaxies. Emission lines like those studied by the team occur when an atom absorbs energy and adopts the physics called an excited state. Eventually, these atoms have to return to their lowest energy state or ground state. That drop back to ground state releases light that, because every element has a unique set of energy levels, is at wavelength and energy characteristic to an atom of a specific element. This means that emissions and light spectra can help identify what elements are present in a star, the atmosphere of a planet, and in the accretion disk around a black hole. Emission lines from stars and other sources take the appearance of thin spikes in spectra, but the violent conditions around a supermassive black hole cause accretion disk emission lines to adopt a different appearance. As matter close to the supermassive black hole is accreted to speeds approaching that of light, associated emission lines are broadened and taken on shallower peaks. The region these emissions come from is referred to as the broad line region of the accretion disk. Again, I'm kind of skipping. The astronomers were also able to determine that the size of the broadline region, estimating that it be an outer radius of 52.43 light days, plus the team was able to calculate the broadline region of the accretion disk is tilted at an angle of 18 degrees in relation to Earth. The team will continue to monitor the quasar, watching as its profile changes over time, as well as considering the use of a near-infrared to study other AGNs. Interesting. And lastly, another one from livescience.com, ghost particles from the sun could lead us straight to an invisible trove of dark matter. Here we go again with dark matter. This is by Paul Sutter. New research suggests that the sun may hold dark matter in its fiery heart, and ghostly particles called neutrinos could lead us to it. Yay! Elusive dark matter particles may lurk deep within the heart of the sun, and researchers have discovered that we can use a detector. Yeah, why I read these articles, why they call to me. Buried in the Antarctic ice sheets to find them. Well, if you're allowed to go there. Dark matter is the inescapable conclusion from decades of cosmological observations, everything from the rotation speed of stars within galaxies to the growth of the largest structures in the universe, points to the existence of some kind of particle currently unknown to physics that rarely interacts with light or with normal matter, despite exerting a powerful gravitational influence all across the universe. As of yet, we do not know the identity of this dark matter particle, so with a relative lack of hard evidence, theorists have come up with dozens of proposals for what dark matter could be. In some of these hypotheses, dark matter does indeed interact with normal matter, but only extremely rare in the densest cosmic environments. A great place for this kind of matter is collected naturally in the interior of the sun. Researchers suggested in a paper that was posted in preprint database. Even if interactions between dark matter and normal matter are exceptionally rare, the density of the sun core, combined with its extremely old age, means that it's had plenty of time for one of its particles to interact with dark matter. Those interactions would sap energy away from dark matter particles, slowing them down until they settle deep within the sun's core. And those dark matter particles can just sit there for a second or a billion years until they interact with another normal matter particle in that dense environment. When that happens, the dark matter particle, if it's heavy enough, can decay into a shower of another, more familiar particle species. Most of those particles will remain trapped within the core, bouncing around in the never-ending frenzy of their fiery environment. But one kind of particle, the neutrino, is capable of escaping the sun. Neutrinos are like almost dark matter. They're incredibly lightweight, by far the lightest known particles, don't have any electric charge, and hardly ever interact with anything else. To detect neutrinos, scientists have to build giant laboratories. The largest of these detectors is IceCube, which uses an entire cubic kilometer of the Antarctic ice sheet as a test chamber. When neutrinos strike water molecules, they create a shower of particles and light that strings sunk into the ice can detect. Wonder why they don't want us going to Antarctica or the North Pole. The sun naturally produces neutrinos as a consequence of its fusion reactions. But in the paper, the researchers reasoned that if dark matter was building up inside the sun's core, and those dark matter particles evaporated into a shower of normal particles, including neutrinos, then we should expect to see a higher number of high-energy neutrinos coming from the sun in the IceCube detection array. However, current neutrino detection rates from the sun are consistent with normal fusion reactions, meaning that if dark matter does exist and is currently building up inside the sun, then those dark matter particles are extremely inefficient at annihilating into normal matter. The lack of detection puts strong limits on properties of dark matter particles. Notably, these are the strongest constraints placed on theories of high mass dark matter theories, and all the data was just sitting there gathered for other purposes. The researchers pointed out, instead of developing new expensive equipment to search for dark matter, they said we should devise clever ways to existing experiments, because we never know what the surprises may turn out. Interesting there. Before I close, I just Googled, and Google's horrible, but just some curiosity killed my little kitty cat here. The largest dark matter detector, Lux Zeppelin, is in the United States. But CERN collects it by the Bose-Heisen accelerator. Now, they don't tell you that they collect it. But I know they have it. And as theoretical and invisible as it seems, get this tidbit. How much would dark matter cost? Discovering just 12 dark particles would be enough to throw all of modern physics for a loop, considering the Lux experiment cost about 10 million to build. That puts the effective price of dark matter at $1 million trillion per ounce. Why I do this research and why I'm so interested in this is that statement right there. So it's a materialist world that people are trying to find these particles, not because it might save the world, but because there's a huge fucking price tag behind it. Keep that in mind. Keep that in mind. You could just Google, I put the largest dark matter collection, and all this shit pops up. So there's a lot here that I read today, and there's a lot of like interesting, like what's in the mountains, what's in the Arctic now. I mean, we only are told what they tell us, not necessarily what we can possibly find in the nether regions of the web. It's important to understand that all this stuff that might not have anything to do with your existence is so a part of your existence, because the wrong move, the wrong experiment could do damage beyond capacity. We're all worried about atomic nonsense and wars and all this shit. Look what they're doing with lasers. So please explain to me, what are they trying? Is this like Atlantis 2.0? Atlantis 2.0, here we are. And unfortunately, these brilliant minds don't know that they, or maybe they do, and they're just wanting that. This is something that should worry most people, because like I said, I get these articles through spirit guides on my Facebook. This is just purely something I've always been interested in anyway. But looking deeper into these things, in the wording of how these things are phrased, there's a lot screaming out that needs to be acknowledged, and there's a lot that not even I comprehend. But at the core of all of this, what happened in Atlantis is speculative, but it fell, it collapsed. Why? Because there was something that was used for the negative polarized beings that didn't want the survival of humans to happen, or whatever. They didn't want Earth anymore. Goodbye. Right? So are we here again? Now, if there's technology that already knows about all this stuff, which I know there is, there's no doubt about it, why are they holding it back? Are they waiting until we're not a materialist society, meaning that we are driven by this and driven more by the heart and by humanity standards. I like I said, since the very beginning of these shows, I feel that humanity, if you're going to do these tests, I don't care how backwoods you are, you and everybody else should have a say in if this goes on. Not these private funded universities and entities. We don't know where all this money comes from. Where does all this money come from? And why is this one piece of Lux Zeppelin? Why is that $10 million? What the fuck? Who funded that and where did that come from? And if it's coming out of the taxpayers' money, excuse me, I should know about it. Plain and simple. This becomes a problem when they are taking control of things that, yeah, most common people are not studying, looking into it, or care less about. Like, who cares about a neutrino? Does it affect your everyday life? Probably not. But what it does affect is if something goes wrong. Or if somebody's taking all these beautiful experiments that could possibly usher us more technologically forward, and it sets us back. Or it's used to harm other people or humanity at large. That's why it matters. And that's why I'm doing this series. I don't care how many people see it or not. I'm reading these articles and I'm questioning it all. Because what is our paradigm? What money is behind all this? Who's paying for all these things? And how do we know what they're really doing in those laboratories? We don't. So, just metaphysical pondering here. Do your research. I just feel that there's a lot of this that we don't really can comprehend on a major scale just yet. I'm trying to source it all together, but I find all of this very unique and different from what other people are talking about. And I do feel that there is a lot more that is being covered up, that there are secret experiments going on, and there always has been. It's just a matter of when are we going to find this out? And it's way too late anyway. But and now we want to know why there's a Mandela effect. Now we want to know why we thought the world was going to end in 2012. There's a lot to uncover with that. I'm still digging. But guys, I hope you enjoyed this episode, or you find this very interesting and intriguing like I do. That's why you're probably listening. Please write in the comments what you think. I love to bounce ideas off of other people. Sending each and every one of you love, light, protection, and shielding. Please don't forget to like, share, and subscribe if this is something that resonated with you or you got something out of it. It just helps me get the algorithm around, get people viewing more. It helps. Thank you. And I want to thank every new subscriber. I've been getting a lot of new people. I want to thank all of you for joining me in my thinking. And again, these are my perceptions, my thoughts. You might not resonate with it. You might not perceive the same thing I am. And that's what makes us unique and lovely individuals. So with that, guys, I hope you guys have a wonderful rest of your week. It's almost over. And I hope to see you on the next one. Bye, guys.